Imagine a stick-man bobblehead riding a rocket. The rocket's initial position is 0 units, the rocket's position at 2 seconds is 6 units, and the rocket's position at 4 seconds is 20 units. Let's first animate this with linear interpolation, meaning our motion graph will connect the key points with straight lines. Blast off in 3, 2, 1. Notice that the rocket moves at a constant velocity between each key frame, and how the velocity jumps at position 6. These are inherent traits of linear interpolation. The point, which is exaggerated by the bobblehead, is that linear interpolation doesn't make for realistic smooth motion. One solution to this is switching to sinusoidal interpolation. We will keep the same keyframes, but change the way the rocket travels between them. Instead of straight lines, we connect the key points with sinusoidal curves. Here is the motion it produces. The rocket does not travel with constant velocity, but speeds up and slows down, achieving a velocity of 0 at the key frames. This creates a much smoother ride for our bobblehead. In hindsight, I'm thinking that the linear interpolation was actually better for animating a rocket, but you get the point. If the goal is smooth motion and endpoint velocities of 0, sinusoidal interpolation is a good option. Stick around and I will teach you how to create sinusoidal motion with a particle in Desmos. The first thing I want you to do is hit this add item icon and add a folder. Name the folder key frames and press enter several times to give you some spaces in that folder. Once you have that set up, go ahead and copy all of this into it. To type subscripts into Desmos, you only need to type in the number if your subscript is a number, so T1 will give you T sub 1. However, if your subscript is a letter, you do need to use the subscript button. We'll do some letter subscripts later. But what you're doing is you're setting up key times and key positions. I'm just using horizontal position. Our animation will just be horizontal motion here. And then go ahead and create a list of your key times and a list of your key positions. Then we can plot all of them at once by typing out a coordinate with the name of those lists. Once you have that, Desmos should plot your 3 key points. So mine I have at 0 seconds, I want my horizontal position to be 2. At 8 seconds, I want my position to be 6. And at 16 seconds, I want my position to be 16. You can set those to be whatever you want. I recommend starting your time at 0, but after that, it is up to you. Also, you have this little edit list icon. If you press that, you now have the ability to change the color and the size of your coordinates. You will not have these bottom 2 colors, but you have 6 others to choose from. The size defaults to 8. I made mine 15 for visibility. Good. Let me show you one feature of using list. This will help make sense of why I typed out the function the way I did. For example, if I want to tell Desmos to recall my second key time, I would type in capital T bracket 2. My second key time is 8. If I wanted to recall my third key position, I would type in capital X bracket 3. Good, these are not universal commands. I'm using capital T and capital X because that's what I named my list. Those names are arbitrary. Okay, now for the formula. So this right here, this is a formula that connects 2 arbitrary points using a sinusoidal curve without oscillation. Now, ironically, I am using cosine. I think it's a little bit cleaner, but that's one way to do this. So now here's what I'm typing into Desmos. It's the same thing, but I'm using that feature of recalling values. So if we start here, F for function, subscript S for sign. That is arbitrary. You can name it whatever you want. I'm using K here for key frame. That is, I'm going to tell this formula if I want it to start at my first key frame or my second. And then here we go. This right here would be the sum of one X position, one key position, and the key position that comes after that. This over here would be the difference of those, and down here would be the difference of the two sequential key times. So I need two of these. We'll go ahead and call the first one f sub 1 for obvious reasons, is a function of time, equals f sub. Now let's use this formula, f sub s. I want it to start at my first key frame, so 1 comma t, and there you go. We see this sinusoidal curve connecting my first two key points. We need one more, f sub 2 of t equals f sub s, and then this is going to start at my second key frame and go to the third. So there you go. You see that connecting the green one is connecting the second to the third. So we're getting somewhere. We need a single continuous piecewise function that crops out everything that we don't need. So let's go f sub p for piecewise. Again, you can call it whatever you want, a function of t equals, and let's go curly brackets here. From the first key time to the second key time, we want to use our first function. Pay attention to the use of colons and commas. From my second key time to my third key time, which is the end of this animation, I want to use my second function there. And we can see this white graph. Let's go ahead and hide the other two. Your Desmos colors are random. You probably have different colors, but go ahead and hide these two. And then I'm going to go to my edit lists and change my color just to the purple that I'm using for consistency. But there we go. Now we have a single piecewise graph that is our position as a function of time. I believe this is called a motion graph, something like that. Good. So now let's use it. Let's go ahead and create another folder. You don't have to create folders. I just like to stay organized. Let's call this animated particle. And this particle is going to be a function of time, and we can control that. So let's go ahead and type in t sub m. I just call this my master timer equals 0. We want it to start at 0. Mine is going to go to 16. That's how long I made my animation. Yours is whatever. Actually, if you want to generalize that, you could just put T3 there, and then now you could change that and the timer will update. And then make your step 0.001. That's really nice, smooth motion. Here, go to animation properties, and let's just play this once in the forward motion. Now, I said that my animation is 16 seconds. That's not true. The length of your animation is completely dependent upon the slider. So even though my slider is set from 0 to 16, if the playback speed is 1, Desmos will play that slider in 4 seconds. That's just how it's been programmed. If I bump that down to 0.5, Desmos is going to play the slider in 8 seconds. And then if you go down to 0.2, that's 20 seconds. So I'm going to go to 0.5, meaning technically my animation is going to be 8 seconds long, but don't get hung up on that. Now let's make our particle the thing that's actually going to move. So this particle's x-coordinate is our function dependent upon our timer. Comma. You could put 0, but then you're going to see down here I have this little point on the x-axis. I'm going to go ahead and set my y-coordinate to be 1 just so I could see it. And then I'm going to change the color and the size. There we go. Save. And that should be it. We're going to hit play here, and we're going to see that blue particle move according to this graph. So it speeds up and slows down, speeds up and slows down again. So there we go. We get this nice smooth motion. So, that was a little bit slow. So I could go ahead and I could change the speed of my animation to 1. So now the playback will be 4 seconds. So yes, there is an inconsistency between the actual playback speed programmed into Desmos and what I have my values set as. So that's a learning curve you have to mess around with. But good. The way this is set up now makes it very easy for us to change things. So let's say I wanted my particle to start and move to the left and then move to the right instead of moving to the right the whole time. So I could make my first key position say 10, and then I want that to move back to 2. everything updates. That's all you have to do. Go back and play your slider, and there we go. It's going to move back and then move forward. So that makes a very nice bouncing video per se. All right, if you change this to just continue a playback, it'll just keep going. So I'm going to let that play there. Good. So limitations. I like to discuss the limitations of this. So your end velocity and your beginning velocity is going to be 0. That is inherent to this. You have no control over the initial velocity or the end velocity. You also have no control over the acceleration at the end points. So that brings us into another type of interpolation that will be the next video, and that is called the cubic Hermite. Now that is mispronounced. Hermite, Hermite, is French, probably off of a French mathematician. But using cubic instead of sinusoidal is going to give us control over the end and beginning velocity, right? That is, those are called degrees of freedom. We're going to have more degrees of freedom than you do with sinusoidal. So that'll be the next video. Thank you for sticking around. I hope you learned something.